We'll continue solving systems today, but by a new method called multiplication. And basically, we're opening the bag of tricks to do a different process. You'll notice in this problem, I could simply, if I wanted to, isolate y and then make a substitution. However, I'm going to show you a different method of solution, once again called multiplication. Now, additions, I like addition probably the most because it's the least amount of work. But you'll see in this case, we can't really add because I don't have opposites. But algebra tells us, once again, whatever we do to one side, we can do to another to benefit us. And if I were to take, and I notice that, hey, this is negative 7y, if this were positive 7y, I'd be super happy. I could multiply both sides of this equation by a negative 7. And in so doing, I would get negative 35x. I get positive 7y. And I get positive 21. And if I look at the top again, I have 8x minus 7y is equal to 6. And you'll notice now I have opposites. So I can take and add these up. If I take negative 35 plus 8, I get negative 27x. And that's equal to 27. Dividing by negative 27 to both sides. I get x equals negative 1. And then I could go back to any of my equations and solve for x. I'll just go right here and say that 5 times negative 1 minus y equal to negative 3. It's negative 5 minus y is equal to negative 3. Add 5 to both sides. Negative y is equal to 2. Divided by negative 1. And y is equal to negative 2. So I have a solution of negative 1. Negative 2 is my ordered pair. And this is multiplication because I multiplied both sides by a value that allows me to add things up and thus eliminate a variable. Likewise, in this example, you see I could use subtraction. It's probably the easiest way to do this since they're opposites already, but since we're using this multiplication method, I'm going to do that. I want an opposite for 3y, and if I multiply the bottom equation by 3, you'll notice I get 6x minus 3y is equal to 3. Top was 2x plus 3y is equal to 6. Adding these up, I get 8x equals 9. Divide by 8, and x equals 9/8. I need to find my y term. So again, I'm going to make a substitution. I have 2 times 9/8 minus y is equal to 1. That's 9/4 minus y is equal to, I'm going to call this 4/4. So I'm going to need to subtract. So negative y is equal to negative 5/4, and y is equal to 5/4. Solution 9/8 and 5/4. Now in this problem you'll notice there's nothing I can multiply 6 by to get 8 in terms of integers, and there's nothing I can multiply 7 by to get 3 and vice versa. So sometimes when we multiply, we have to multiply both equations by possibly a different number. I noticed that if I look at 7 and 3, if I multiplied 7 by 3 and 3 by 7, I get 21 and negative 21. Those would be opposites, which is what I want to do. So I'm going to multiply the top by a 3, the bottom by the 7, and then I'll get opposites. The top is going to be 18x minus 21y equals 33. The bottom will be 56x plus 21y is equal to 329. And that's the only disadvantage to this sometimes is our numbers get pretty big, and that 329 is actually a negative. So then I'm going to add these up. I get 474x is equal to negative 329 plus 33 is negative 296. Divide by 74 to both sides. And that's going to give me a total of negative 4. I've got to find y, so I'm going to plug back in. That's 8 times negative 4 plus 3y equals negative 47. Negative 32 plus 3y equals negative 47. Add 32, get 3y is equal to negative 15. Divide by 3 to both sides and get y is equal to negative 5. Therefore, I've got an ordered pair of negative 4 and negative 5. And let's do one more. Again, no integer multiplied by one of the two equations will get me the opposite of the other. So I'll multiply the top by, let's go 2, and the bottom by 5 so that my y's go opposite. I have 6x plus 10y is equal to negative 18. Then I have 25x minus 10y is equal to 80. 31x after I add is equal to 62 divided by 31, and x equals 2. Substitute 5 times 2 minus 2y, 16, that's 10 minus 2y is 16, subtract 10 to both sides, negative 2y is equal to 6, divide by negative 2, and y is equal to negative 3. So I have 2 and negative 3. And I think that's all we've got. Write your summary, solve the two problems, and we'll talk tomorrow.